Hey everyone, and welcome. Today we're jumping right into a really important topic for any modern network, multicast, specifically within a Cisco SD-Access fabric. We're going to break down how it all works, look at the different ways to do it, and cover what you absolutely need to know to get it up and running. So, let's dive in.
Alright, so here's what's on chat for this explainer. We're going to kick things off with the fundamentals, just to make sure we're all on the same page. Then, we'll get into the two main ways to handle this, native and overlay multicast. After that, we'll look at a special feature called Layer 2 flooding, and we'll wrap up with how you can make all of this work in a network that already exists.
Okay, first things first, let's build a solid foundation. Before we get into all the SD-Access nitty-gritty, it's super important that we understand what multicast is at its core, and maybe more importantly, why we even care about it. So what is multicast, really? Well, it all comes down to being efficient with your network's resources. Imagine you need to send a live video feed to 100 people. Instead of your server sending out 100 separate identical streams, clogging up your network, it sends out just one. The network itself is then smart enough to replicate or copy that stream only where it needs to go. It's a game changer for things like IPTV, big video conferences, or even stock market data feeds. So how does the network figure out these efficient paths? Well, it mainly uses two methods. First, you have something called a shared tree. Think of this like all traffic having to go through a central meeting spot, which we call rendezvous point, or RP. But for a much better route, the network can switch over to what's called the shortest path tree. This is exactly what it sounds like. It creates the most direct path possible from a specific source to a receiver, using a protocol called PIM Source Specific Multicast, or PIM SSM. Now inside an SD-Access fabric, this leads us to two main strategies. You've got overlay multicast, which is simpler to set up because one main device does all the work of copying the data. And then you have native multicast, where the physical network itself, the underlay, handles all that copying, making it way more efficient and scalable. The big takeaway here is that it all comes down to where that replication happens. Let's dig into both.
All right, time for our first deep dive, native multicast. The whole idea behind this approach is to really use the power and intelligence of your physical network infrastructure, what we call the underlay.
So native multicast is basically you telling your SD-Access fabric, hey, let the physical network do what it does best. You're pushing that replication job down into the core network. This means your physical routers and switches are now in charge of copying those multicast streams. Now, it does mean you have to configure your underlay for multicast, but trust me, the performance payoff can be absolutely huge.
So you might be asking, why go through the trouble? Well, the benefits are pretty clear. You take a massive load off your main head-end devices. This lets you scale up way more effectively, and it cuts down on latency because the data is taking a more direct path. And as we're about to see, it's the only way to enable another key feature, Layer 2 flooding.
And this diagram just shows it all perfectly. The source sends one stream into the fabric. But instead of the main rendezvous point doing all the heavy lifting, it just passes that single stream down into the underlay. From there, the physical network devices, the routers and switches, intelligently copy the traffic only out the ports where receivers are waiting. The head end is just a waypoint, not the workhorse.
Okay, so that's native. Now let's flip the coin and look at the other side of this, overlay multicast. If native multicast is all about pushing the work down into the underlay, overlay is about pulling all that work up to the head end.
With overlay multicast, your physical underlay's job becomes dead simple. Just get packets from point A to point B. That's it. All the multicast smarts live in the virtual network, the overlay. This means that a single device, your head-end router, is now responsible for handling all the replication.
Now take a look at this traffic flow. It's a totally different picture, right? The source sends its stream up to the fabric RP, and that device becomes the replication engine. You can see it right there. It makes two separate copies of the data and sends each one down through the underlay to the specific edge switches that need it. The underlay is basically just a dumb transport pipe here. Putting them side by side like this, man, it just clicks, doesn't it? On the left, with native, the replication work is distributed throughout the physical network. On the right, with overlay, all that work is centralized on one device. It's the classic network engineering trade-off, distributed efficiency versus centralized simplicity.
Okay, let's switch gears a bit and talk about a very specific feature that builds on all this, especially on native multicast. It's called Layer 2 flooding, and it's not turned on by default for a very good reason.
You see, by design, an SD-Access fabric is like a quiet library. It hates unnecessary noise like broadcast traffic and tries to eliminate it. But some applications in older devices, think of things like silent hosts that don't announce themselves or old card readers, they actually need broadcast traffic to work. Layer 2 flooding is the button you press to allow that kind of traffic, but only within a specific subnet where it's absolutely required.
Now, a few key things to remember. This is off by default for a reason, so you really want to use it sparingly. It's specifically designed for broadcast and local multicast traffic. It won't flood unknown unicast packets. And here's the kicker, the most important dependency. You cannot enable Layer 2 flooding unless your fabric is already configured for native multicast in the underlay. They go hand in hand.
And for all of you managing a fabric out there, you're probably wondering, okay, where is the button? Well, here it is. Inside Cisco DNA Center, you just go to your fabric domain, head over to Host Onboarding, and find the virtual network you need to tweak. From the Actions menu, it's just a simple click to enable Layer 2 flooding. Super straightforward.
All right, last but definitely not least, let's talk about the real world. Most of us aren't building a brand new shiny network from scratch, right? We're integrating SD-Access into a network that's already up and running, what we call a brownfield environment, and that comes with its own set of rules. This picture here really shows what that looks like. You've got your new, cool SD-Access devices, your edge and border nodes, and you've got to make them connect and talk reliably across your existing LAN. And to make that happen smoothly, you have to meet some pretty important requirements first.
These are pretty much non-negotiable for your existing underlay. Your routing has to be solid and stable. You need clean point-to-point Layer 3 paths between all your fabric devices. And this last one is so important. Your MTU, your maximum transmission unit on all your links, has to be big enough to handle the extra data that VXLAN encapsulation adds. Seriously, don't overlook that one. It's a super common gotcha.
Okay, this table is super important, so let's walk through it. Look at the top row. If you want to use Layer 2 flooding, your network has to support PIM ASM, and you need a rendezvous point configured for that 239 address range. Now look at the second row for native multicast. For that, you need PIM SM support for the 232 range, and notice, no RP is required. The most critical thing for both is that these specific group addresses cannot already be in use anywhere else in your network.
And that really brings us to the final question, the one you have to answer for your own network. After seeing the trade-offs, which strategy is the right fit for you? Are you going to prioritize the simplicity and easy setup of overlay multicast? Or do you need the raw efficiency, the low latency, and the massive scale that comes from doing native multicast right? The answer, as always, really depends on what your network and your applications need to do.